A massive city weighing more than 100,000 tons sits inside a canyon protected by massive walls. With just a press of a button, millions of gallons of water rush into the dock, lifting a colossal warship from the ground and straight into the ocean. But not every method of launch is the same. When space is tight, the Navy needs to come up with a new plan, one perfected by the Dutch, enabling them to take a vessel from the shore and drop it into the water sideways. Precision is key. The stakes are high, but when the going gets tough, no one can rival the ingenuity and cunning of the United States Navy. Today, we'll explore how the United States can defy gravity, launch hundreds of thousands of tons of American steel in the water, and how they have become the most feared Navy fleet in the world. And if you are truly proud of our Navy, type "proud" in the comments below. Launching modern Navy ships. Launching modern Navy ships is nothing like you see in old movies. There are no wooden ramps with oil for the vessel to slide down, and the days of champagne bottles smashing against the hull are something left in the past. Now, we are talking about billions of dollars, hundreds of thousands of tons of steel, and vessels big enough to sustain an entire city for a few months on end. It takes precision, as the USS Harrisburg proved in October 2024. When the Harrisburg was first launched from the first LPD Flight II San Antonio-class amphibious transport dock, it took technology and ingenuity that would blow your mind. With its ability to carry 700 Marines, their vehicles, aircraft, and even landing craft, it is the size of an 8-story building. The only difference is that this building costs about $1.8 billion. Using a translation railcar system, it is similar to rail tracks, but in the water. To get it ready for launch, engineers begin by flooding the dock, which naturally lifts it from the ground. The railcar system is activated, launching it forward to the mouth of the dock, where several hovercrafts take over. These hovercrafts move at about 40 knots, where they magically steer the vessel into the deep ocean. And within a couple of hours, the USS Harrisburg was ready to deploy and protect U.S. assets all over the world. The USS John F. Kennedy CV-79. Then there is the launching of the USS John F. Kennedy, a Gerald R. Ford-class aircraft carrier that was launched on October 29, 2019.
John F. Kennedy, may God bless this ship and all who sail in her.
But compared to the USS Harrisburg, this aircraft carrier is far bigger and, well, more interesting. It stretches more than 1,000 feet in length and over 250 feet. That's about 3 football fields, with a few end zones to spare. The one problem with these aircraft carriers is how they are built. Unlike conventional warships, constructed piece by piece and then fully assembled inside a dry dock, the aircraft carriers are built from the keel up. This means that it is one continuous structure sitting on the keel blocks, with various compartments perfectly installed. These keel blocks essentially need to support 100,000 tons for the better part of 4 years as the vessel is constructed. More than 3,200 shipbuilders undertake this massive job, installing the best of everything, including radar, electronics, a perfectly shaped hull with guns and cannons that can ruin the day of anyone who dares mess with the US of A. Yet, on October 29, 2019, this massive city was ready for one of the biggest launches in US history. Hundreds of shipyard workers spent weeks preparing for this day, ensuring water pumps were working, the vessel was secure, and most importantly, it wouldn't sink. As the time broke, a perfectly orchestrated flooding process was activated by the press of a button. Water began flooding the dock, but only about 10 feet high to cover the keel blocks. This is where the true ingenuity of U.S. engineering takes over. With numerous engineers starting what is called the testing period, once they receive the all clear, more water is slowly poured into the dock, and the laws of physics begin taking their effect. The vessel slowly experiences the power of buoyancy, floating on the water inside the docks. Within a few more hours, about 100 million gallons of water rush into the dry dock, filling it to the brim, and the Kennedy is no longer dependent on its keel blocks. This is the most stressful time, with engineers scurrying to finish up tests and check that the vessel is fully supported by its own hull. Once given the all clear for a second time, she is moved to the west end of the dry dock, where another few months of testing are done before christening. But this movement process by itself takes incredible skill, with tugboats maneuvering it millimeter by millimeter until she is in the perfect position. Every movement is calculated when you move a weapon more valuable than the GDP of many African countries. Then, nearly 2 months later, on December 7, 2019, she finally got the nod. Pearl Harbor Day, a time to remember that fateful day in 1941, would be her first day on the ocean. None other than Caroline Kennedy would perform the christening, smashing a champagne bottle against its bow. Something she had done 52 years prior when the first USS John F. Kennedy was christened. But even then, it would take months more testing near U.S. shores before she would finally be given the nod to enter the vast ocean. And finally, she makes her first voyage, showing off her power and striking fear into the hearts of anyone who dares try to mess with U.S. interests. Unfortunately, launching vessels like this is not always possible, and when room is limited, the U.S. Navy needs to rely on a different method, one perfected by the Dutch with their small shipyards and waterways. Launching a warship sideways. When limited space is available, or when waterways are too narrow, navies must rely on a different method that helps get a ship into the water. While not native to the Dutch, they have a problem with narrow waterways, being forced to launch even freighter vessels sideways. Instead of flooding a dock like more conventional launching methods, a set of hydraulic ramps is used. The vessels are placed on these ramps, and a large crowd is usually entertained by a speech before the momentous occasion. Once the bottle of champagne strikes the vessels, it is slowly launched into the water via a hydraulic ramp. Yet this needs to be done extremely carefully. Too much speed and the vessel will tip, so every second needs to be calculated and precise. But the Dutch are not the only people to use this method of launching vessels. In fact, the United States has its own port that makes this possible. In 2018, the Freedom-class littoral combat ship, LCS-19, the future USS St. Louis, was one of the first warships to be launched sideways. It only took a few minutes for the USS St. Louis to go from dry ground to being a 3,900-ton warship that tumbled into the icy water of the Menominee River on its side. According to Joe DiPietro, Lockheed's vice president of small combatants and ship systems, the method was used because the size of the ship and the capabilities of the shipyard allow for a side launch. He continued, the ship has a shallow draft. It requires less than 14 feet of water to operate in, and is a small combatant, about 381 feet long, and can therefore be side-launched, where many other ships cannot. Yes, the problem is that only a handful of warships can possibly be launched in this exact way. But now the United States is planning to upgrade many of its ports to further bring military excellence. Upgrading U.S. naval ports. One of the biggest upgrades will be to the Pearl Harbor Naval Shipyard, which is getting the most expensive construction project in Navy history. It will cost a whopping $3.4 billion to create a dry dock that is specifically designed for the newest submarines. And it is suggested that the shipyard will be functional for at least the next 150 years. More specifically, it will focus on the launch of the Virginia-class attack submarines. while the newer Colorado-class ballistic submarines will also be launched from the same port. However, Norfolk Naval Shipyard, located in Virginia, is also undergoing a wealth of upgrades, with its dry dock having a $300 million renovation that is mostly dedicated to the new Gerald R. Ford-class aircraft carriers. Some of its improvements will ensure that the risky sideways launch method will no longer be needed for warships that cost billions of dollars. In essence, the dock is getting saltwater cooling systems, improved pumps, and faster flooding capabilities. Should Puget Sound Naval Shipyard also receive the same upgrades, it means that the United States has the capability of launching virtually every vessel in a safe manner from a dry dock. But is it safe to launch a vessel sideways? Safety concerns. One of the biggest risks with the sideways method is that testing is almost impossible. Unlike dry dock flooding, where the water levels are slowly raised, this method dumps the vessel directly into deep water. During the dry dock launch, water flows into the dry dock, only enough to see if it can float. Once engineers have conducted all their testing, they instruct the operator to allow more water to flood in. This is critical to ensure buoyancy. However, one crucial error or defect from a sideways launch could see billions of dollars at the bottom of a river or canal. As I mentioned earlier, launching a ship sideways is also like a choreographed dance, which requires incredible precision, especially when it comes to the calculation of weight, gravity, and the speed at which the hydraulic ramps allow the vessel to slide into the water. If just a single ramp fails, the ship could slide uncontrollably, possibly capsizing or even damaging itself. Finally, there's the issue of defects. If defects are missed, the ocean will reveal them, and it is not like the vessel can quickly be pulled back to shore. Any maintenance will have to be done at the dock, if the vessel can even make it to the dock. So, while launching a vessel sideways might be something everyone is excited to see, for those engineers and naval officers, it is a tongue-in-cheek moment that can go horribly wrong. But what could go wrong? The worst-case scenario. You'd be forgiven to think that sideways launching has fewer risks than simply allowing it to gain buoyancy from the dry dock. And while it could feel safer when it is launched by expensive machinery, there is still a lot that can go wrong. One of the most important issues that often give in is the hull. The reason for this is the sudden change in stress. Most often, the hull isn't stress tested enough, which means the engineers have no idea if it can take the sudden bump or impact from sliding off the ramp. Since the hull carries the brunt of the force, it can crack on impact if not carefully planned, which will allow water to seep into the vessel and cause a whole new can of problems to be opened up. Secondly, momentum might be a little off. If you look at exactly how it slides down the ramp, you will notice that momentum starts building up, also known as static energy. When the vessel is finally near the edge of the water, it then converts that energy into kinetic energy during the fall process in the water. Once the vessel enters the water, it begins to bob and weave from side to side until stabilizing. But if this is not carefully calculated, you might find that it overextends to one side, causing it to tip over. It might even tip to the port side, which can cause further damage. This is one of the biggest risks faced by the Dutch when launching vessels sideways into various canals or small rivers. A famous example of this is the 1883 Daphne disaster. While technology has significantly improved since the 1800s, the same laws of physics apply, and in that specific case, the vessel capsized immediately after being launched, killing more than 120 people in the process. So, it is certainly not the easiest of processes, and one that definitely takes a lot of skill, planning, and effort to pull off. But to prevent another such disaster, drag chains have become common in the sideways launching of ships. These are chains mounted to the ship and a structure inside the pier or port. Once the cables from the launch side let the vessel slide into the ocean, the drag chains are critical in keeping it afloat by making sure that momentum is controlled. But the final error often made by many engineers is not selecting a large enough waterway. In terms of the physics, this can make the launch more dangerous, not leaving enough room for the water to disperse upon impact. The water will then still disperse due to the weight of the vessel, but it usually spills over into the dock, which naturally makes the surrounding areas more dangerous. This can lead to injuries and even death for bystanders on the side. So, what's the number of ships the United States has launched sideways? Historical successes. To date, estimates show that the United States have launched about 16 warships using the sideways method. This includes the USS Freedom, LCS-1, USS Fort Worth, LCS-3, and the final one, USS Cleveland, LCS-31, launched in April 2023. It doesn't include historical launches, such as during World War II, when escort and auxiliary vessels were commonly launched in such a manner. During the war, the Great Lakes, with its vast bodies of water, were often used as a way to test if a vessel could be launched sideways. These could have numbered in the hundreds, given the effective engineering and industrial magnitude of the Americas during this time. If they could get thousands of tanks off the production line each month, the same is probably true for warships. Perhaps using this method is great for landlocked countries, who often don't have the bodies of water to launch a vessel, but need to rely on rivers and waterways that flow to the sea to get their vessels to the ocean. Yet, they still need to rely on their neighbors to be able to get the vessel through these rivers and have it safely reach the open ocean. But can ships use traverse methods for getting a ship out of the ocean? Can a ship be traversely taken out of the ocean? While it won't be possible to take out large vessels such as destroyers or aircraft carriers, removing small escort vessels from the water using traverse haul-out is possible. It is the same process as dropping it in the ocean and needs a pulley system that often lifts the weight out of the water before placing it on the side. Once again, this is an extremely risky procedure, which involves stabilizing the vessel and ensuring that the hull is strong enough not to snap. Unfortunately, no equipment is available to successfully pull out a vessel, such as an aircraft carrier, from the water in such a way. As impressive as this is, it is one of the riskiest methods of launching a vessel. However, once it touches water, it can turn into a city at sea. And if you'd like to find out how these sailors survive on these ships for months on end, make sure to check out this next video.